Okay, this video is probably going to be the longest on this worksheet because this has kind of like the most stuff to cover. Okay, but finally, for topic 3, we're going to learn how to simplify fractions. Now, before we get into the definitions and the different methods, I will tell you there are two methods, and ultimately, what most students do is they kind of combine the two methods, which at the end of the day, I am fine with. As long as you know how to simplify a fraction by one or the other or a mix of the two methods, that's fine. Okay. Now, as for definitions, we have the equivalent form of a fraction where the numerator and denominator have no common factors is called simplest form or lowest terms. Okay. So if you want to reduce a fraction or simplify a fraction, our goal is simplest form or lowest terms. Okay. Now, the process of writing a fraction in lowest terms is called simplifying or reducing. So directions could say reduce your fractions, directions could say simplify your answers. Just know that either of those, your goal is to seek out lowest terms, okay? Now, we have two methods, I already told you that. And the first one, we do need a definition to understand the first method. So we have something called the GCF in math. The GCF, also known as the greatest common factor. I will generally call it the GCF just because the greatest common factor is a mouthful and it's a lot to write. But the GCF is basically, if you're looking at the greatest common factor of a pair of numbers, it's the largest factor both numbers have in common. It's quite literally exactly what it's called. It's the greatest factor things have in common. Okay. So those definitions are all really important, but for now, let's go ahead and dive into the two methods for simplifying fractions. I'm going to kind of outline them both, and then we're going to practice each one individually. Then we have a couple of application problems. Okay, so the two methods for simplifying fractions are using the GCF, which is the greatest common factor, or using prime factorizations that we talked about a couple of videos ago. So if you're using the GCF method, what you do is you find the greatest common factor between the numerator and denominator, and then you just divide both by the GCF. That's all you have to do. So if you can seek out and figure out what the greatest common factor is, just divide your numerator and denominator by that, and you'll get lowest terms. Now, if you're going to use the prime factorization method, I'll say this, the prime factorization method generally takes longer, but if you've got kind of a nasty fraction that you're struggling with, go to the prime factorization method because it's kind of always going to work. All right. So when you have the prime factorization method, what you do is you find the prime factorization of the numerator and the denominator. And then you look to see factors that the numerator and denominator have in common. And you can't, I want to get a little bit, above board here, but we say things cancel out. It really just means they divide to become one, but we cancel out factors that are common to the top and bottom. And I'll show you exactly what I mean when we get into that. So example 6 says simplify each fraction using the GCF method. Now, in years past, I would spend a ton of time teaching you all how to find GCFs, and it got so cumbersome and students would get frustrated because it's really not a hard thing, but sometimes learning the process was as hard as just finding the darn GCF. So here's kind of the way I approach this, just sort of in my head. I always look at the smaller of the two numbers. So when I look at part A here, I have 24 and I have 36. I'm going to start with 24. And the first thing I ask myself is, will 24 divide into the other number, in this case 36, evenly? Well, no, 24 will not divide into 36 evenly. And if you can't see that, you can go to a calculator. When you take 36 and divide it by 24, you'd get a decimal. So then I start looking at factors of 24. So I know 24 is not the greatest common factor. It does not divide into 36. So I want to start thinking about factors of 24. So factors of 24. Well, 1 and 24, those are factors. We already know 24 doesn't work. So let's see, 2 and 12. Let's go ahead and just try 12. That's the next biggest factor because we would then go 3 and 8 and then 4 and 6. So always kind of go biggest to smallest. So the next biggest factor is 12. Does 12 go into 36? And the answer is yes. So we have now found the largest factor that 24 and 36 have in common. So again, I go to the smaller of the two numbers and I see if that number divides into the other number. 24 does not divide into 36. So then I start looking at the factors of 24 and I go through the list of factors for the smaller number, highest to lowest, until I find one that's common to the other. So 12 here is the GCF. So then what I do is I take both numbers in the fraction and I divide them by the GCF. Well, 24 divided by 12 is 2. 36 divided by 12 is 3. So my final reduced version of this fraction is 2/3. It's not too bad, right? Now, the harder part of this is honestly figuring out what the GCF is, but once you have the GCF, it's a really easy process. And you can always check your work. That's the really, really cool thing here. Anytime in math, if you have a trick to check your answer, that's always a cool thing, right? So we can check by seeing if the initial fraction is equivalent to the reduced fraction. So we would check by saying, is 24 over 36 equal to 2/3? Okay, so we cross multiply. We want to know, does 24 times 3 equal 36 times 2? Well, you can go to a multiplication table for, well, not both of them, so maybe a calculator. But if you were to take 24 times 3, you would get 72. If you were to take 36 times 2, you would get 72. 72 equals 72 equals 72. So the fractions are equal. So we know 2/3 at least equals 24 over 36. And you can look at 2 and 3. Since they're both prime, they have no common factor. So you always want to check your final answer, make sure it's equivalent to what you started with, and make sure that the numerator and denominator no longer have common factors. So this right here is definitely lowest terms. Okay, so next up for part B, we have a negative fraction. Now, when you have a negative fraction, that just means the reduced version is going to be negative. So we're just going to carry the negative over. Don't worry about it when you're looking at the GCF and all that stuff. So let's look at 28 and 42. So we ask ourselves, does 28 go into 42 evenly? The answer is no. And if you're unsure of what I mean, if you go to the calculator, if we were to take 42 and divide it by 28. For 28 to be a factor of 42, I would have to get a remainder of 0, which means I would get like a whole number answer. Well, when I take 48 and divide it by, or when I take 42 and divide it by 28, I get an icky, well, I get a nice decimal, but I get a decimal. So that tells me 28 is not a factor of 42. So that's what I mean when I say 28 doesn't go into 42. All right, so since I know that 28 is not a factor of 42, I want to start listing out factors of 28. Well, 1 and 28 are definitely factors, but we already know 28 doesn't work. 28 is definitely even, so 2 and 14 are factors. 3 doesn't go into 28. 4 goes into 28. 4 and 7. 6 and 5 don't go into 28. We get to 7, so we start repeating. So these are all of the factors of 28. So we want to go through these highest to lowest. So we've already checked 28, it doesn't work. So then we want to look at 14. Well, does 14 go into 42? So ideally, as you go through this class, your multiplication tables will get easier and easier. But if you're still struggling with this, go to your calculator and you want to know, is 14 a factor of 42? So you would divide. And if we get a whole number, yes, it's a factor. If we get a decimal, no, it's not. And when we divide by 14, we get 3. So we know that 14 is definitely a factor of 42. It is also a factor of 28. So that's our GCF. So the GCF here is 14. So I take my fraction, I take 28 and I divide it by 14. I take 42 and I divide it by 14. And I'm just going to carry my negative throughout this process. Well, 28 divided by 14 is 2. 42 divided by 14 is 3. And not on purpose, we get 2/3 again. So we get negative 2/3. And if you want to check this, you certainly could. You could do the cross product between 28 over 42 and 2 over 3, and you'll get that the cross products match. And then you can already see that 2 and 3, they're prime. They don't have any common factors, so you're done at this point. So that is the GCF method. Now, what makes this method hard is finding the GCF, but if you quickly come upon the GCF, it's really, really easy to reduce using that method. Now, let's look at the prime factorization method. So if you look here, we have 4 examples of the prime factorization method. I'm going to show you the full prime factorization method for just the first 2. And then for the last 2, we'll kind of do the hybrid thing that a lot of students are accustomed to. Okay, so the directions for example 7 say simplify each fraction using prime factorizations. So what you do is you find the prime factorization of the numerator and the denominator. Okay. So let's start with part A. We're going to look at 64 first. So 64, we need any two numbers that multiply to give us 64, okay? You can certainly use a calculator to help. You could certainly go to a multiplication table to help. It depends on each person. There are several ways to get the prime factorization, and it all depends on which factors you choose initially. So I could have several of you do this exact problem differently, but the final answer would match. So for me, I happen to see this as 8 times 8. I know that 8 times 8 is 64. Okay, so those would be the factors I use. You could use 2 and 32. There's other ones you could use, but like that's what I'm going to use. Okay, now 8, not prime. So I need to take two branches down from each 8. So 8 is always going to be 2 times 4. 2 is definitely prime, but 4 is not. So I need to have two branches come out of each of my 4s. So I'm going to bring my 2's down and then make branches out of my 4s. So I have 2 times 2 times 2 times 2 times 2 times 2. So that's my prime factorization for 64. And when you're simplifying fractions, you do not want to write it in exponential notation. Just leave it exactly as is. Now for 20, you could do 2 and 10, or you could do 4 and 5. I'm choosing to do 4 times 5. So 4 is not prime, so I need two branches coming out of the 4, each of 2. 5 is prime, so I just bring it down. So then what I do is I take my 64 over 20 and I rewrite it. I'm going to rewrite it as 2 times 2 times 2 times 2 times 2. So let's see, 1, 2, 3, 4, 5, 6. So 6. And then 20, I'm going to write as 2 times 2 times 5. And what we tell students is we say, look for common factors that are in the top and the bottom that we can cancel out. We use the word cancel in math all the time. What we mean is, are there numbers in the top and bottom that when we divide them, we get 1? That's really what we mean by that. And if you look here, let me get this. I'm going to go maybe to red. If I look right here, I have 2 divided by 2. Well, 2 divided by 2 is 1. So that kind of cancels to become just a 1. It leaves like a little footprint of a 1. I have another 2 times 2. Well, 2 divided by 2 cancels and just becomes a 1. But now if I look at the top, I've got just 2's. If I look at the bottom, I've just got a 5. There are no other common factors. So I multiply what's left over. So 2 times 2 is 4, times 2 again is 8, times 2 again is 16. And then 5 is just 5. So the simplified answer here is 16/5. And if you wanted to, you could check your cross products between 64/20ths and 16/5, and you'd get that your cross products do match. But even more importantly, check 16 and 5. They have no common factors. 5 is prime, and since it's not a factor of 16, we know we caught everything. So 16/5 is your final answer. All right, for part B, we have negative 28/60ths, okay? So this is negative, so the reduced answer is also going to be negative, so just make sure you carry that negative through. It doesn't really become part of the simplifying process, it just gets carried over, okay? So when I do my prime factorizations for 28 and 60, I don't have to worry about signs or anything. Okay, so let's talk about 28. So we need any two numbers that multiply to give us 28. We could use 2 and 14 or 4 and 7. I think I'm going to use 4 and 7. You could certainly use 2 and 14. Your tree will look different, but the final row will be the same. So 4 times 7, 4 is not prime, so I need two branches coming out of the 4, both the 2. And then 7 is prime, so I just bring it down. So that's my prime factorization for 28. And then for 60, we have several different ways that we could write 60. We could do 2 times 30, we could do 3 times 20, 4 times 15, 5 times 12, 6 times 10. All of those work, doesn't matter which pair you use. I like 6 and 10, so those are the two that I'm choosing to use. Neither of these are prime, so I make branches come out of both of these. I'm going to rewrite 6 as 2 times 3 and 10 as 2 times 5. And they're all prime now, so I'm done. So I'm now going to go and rewrite my initial fraction. Remember, it was negative 28 over 60. So again, the negative isn't really part of this calculation. It just needs to be carried throughout the problem, okay? Now I'm going to rewrite that as negative, and then my numerator is 2 times 2 times 7. And then my denominator, I am going to write my factors in order just because I think it'll be nice here. I get 2 times 2 times 3 times 5. And again, I want to look to see if I have factors that are common in the top and in the bottom, because when I divide them, I get a 1, which is really nice. So 2 divided by 2, really just 1. 2 divided by 2 again, really just 1. So if I look at my numerator, I just have 1 times 7. Don't forget your negative. And then when I look at my denominator, I have 3 times 5, which is 15. So if you want to do the cross product thing to check 28/60ths and 7/15, you'll get that your cross products do match. But even more importantly, 7 is prime and it is not a factor of 15. So we know that we are fully reduced. Okay? So that is the prime factorization method. So you've seen the GCF method, 2 examples. You've seen the prime factorization method, 2 examples. Ultimately, what a lot of students do is they kind of merge the 2 methods. So they maybe don't find the greatest common factor, but they find a common factor and they divide it out. And then they just repeat that process until they get a fully reduced fraction. So we'll kind of look at that method for the last 2. So for part C, we have negative 49 over 98. Now, this is a negative fraction, so remember, the negative is going to have to be in our final answer, so we're just going to kind of carry it through our process. So when I look at this, I'm like 48 and 90, or 49 and 98. Ooh, those are kind of wacky numbers. I do know that 49 is divisible by at least 7. So let's see if 98 is divisible by 7. So you can go to your calculator, or you can do it by hand. So I want to know, does 7 divide into 98? Well, 7 goes into 9 once. I subtract the 7 and I get a 2. Then 7, let's see, goes into 28 4 times. Well, 4 times 7 is 28, so I get a 0. So yes, 7 is definitely a factor of 98. Okay, so that tells me right here that a common factor between these two is just 7. So I'm going to divide top and bottom by 7. So it's kind of like a weird little 1 that I'm doing here again. But 49 divided by 7 is 7. 98 divided by 7 is 14. Don't forget this is negative. Well, darn, looking at 7 and 14, I know they have a common factor. 7 happens to also go into 14, so I'm not done yet. I've reduced it part of the way, but it is not in lowest terms. So I need to do that whole process once again. I know that 7 is a factor of 7 and 14. So I'm going to just do the process again. I'm going to divide by 7 one more time. And I get 7 divided by 7 is 1. 14 divided by 7 is 2. And if you doubt yourselves, remember, you can always check it. So I've only checked it once again prior, so let's check it again. We want to really know, is 49 over 98 equal to 1 over 2? I'm not going to worry about the negatives. I know if a fraction is negative, its reduced form has to also be negative. So we're just going to look at this right here. So I want to know, is 49 times 2 equal to 98 times 1? Well, let's see what 49 times 2 is. 2 times 9 is 18. I carry a 1. 2 times 4 is 8 plus 1 is 9. There you have it. 98 equals 98. So those 2 fractions are for sure equal. So again, we kind of did the GCF method where we divided out a common factor. We just had to do it 2 times before we got our final answer. So again, it's kind of merging that idea of the least common factor by dividing out all common factors. We just do it piece by piece. All right, next up we have 90 over 120. I'll tell you this right now. If a number ends in 0, it is definitely divisible by 10. Okay, so these are for sure both divisible by 10. Excuse me. Now, the trick is if 90 is divisible by 10, all I have to do is knock off the 0, and that tells me what I multiply 10 by. So 90 is divisible by 10. So if I just take the 0 at the end of 90 and knock it off, that tells me 9 times 10 is 90. So 10 goes into 90 9 times. So if I take 120, I know it's divisible by 10 because it ends in 0. If I knock that 0 off at the end, that tells me I take 12 and multiply it by 10. So 120 divided by 10 is 12. Now looking at 9 and 12, unfortunately, they do have a common factor, so we're not done yet. So 9 is not going to go into 12 evenly. So I need to start thinking of what are some factors of 9? Well, 3. Does 3 go into 12? Yes. Excuse me. So I need to divide top and bottom by 3. So 9 divided by 3 is 3. 12 divided by 3 is 4. And there you have it. We get 3/4. So 3/4 is equal to 90 over 120. You can do the cross product thing to check if you have any doubts. And then 3 and 4 definitely have no common factors. 3 is prime. It's not a factor of 4, so we're done. Okay? I need some water. Okay, 2 more really quick examples. So we've got just kind of some application problems, just some little word problems here. So the directions say solve, write each fraction in simplest form. So for part A, it says there are 5,280 feet in a mile. What fraction of a mile is represented by 2,640 feet? So the fraction we want to create, we know the denominator is going to be the number of feet in a full mile. We then want to take that portion of a mile, the 2,640, that's going to become the numerator. And well, let me make that it's a little gregarious up there on top. So 2640. Now, anytime numbers end in 0, they're divisible by 10. So we want to simplify this. And I know you're like 4-digit numbers. You want us to simplify that. I'm not a monster. I swear this isn't so bad. So they're both divisible by 10. So when I divide by 10, I just knock 1 0 off. So 10 will go into 2,064, 2,640, 264 times. And 10 will go into 5,280, 528 times. So you just knock that 0 off. And so you're like, good Lord, they're still going to need to be reduced because 4 and 8, if a number ends in 0, 2, 4, 6, or 8, it's even. So these numbers end in 4 and 8, so they're even. So you could just divide by 2. So let's see, 264 divided by 2, that's going to be 132. 528 divided by 2 is going to be 250 plus 14, 264. And I'll be doggone, they're even again. But in this case, it's not so bad. So if you look at 132 and then you look at 264, do you notice a relationship between them? Hopefully you notice that 132 will definitely go into 264 exactly twice. So we can now divide, even though it's crazy, by 132. And we get 132 divided by itself is 1, 264 divided by 132 is 2. So after a lot of, panic and heartache, we get that this is really just 1/2. So 2,640 feet is 1/2 of a mile. And if you have any doubts, I will show you this to be true. So if I take 2,640 and I multiply it by 2, I get 5,280. So I can tell you right now that 2,640 is half of 5,280. Okay. Now there is a way for this calculator to reduce fractions for you, but that would be way too fun for me to show you that, right? Maybe one day. Okay, finally, B. A box of dog biscuits contains 78 treats. So we know that's the entire box of dog biscuits. What fraction of the box is left if your dog has eaten 60 treats? Well, we know that 60 is divisible by 10, but unfortunately 78 is not. However, 60 and 78 are both even because they end in 0 and 8. So let's go ahead and just start by dividing by 2. Well, 60 divided by 2 is 30. 78 is a little bit harder, so if you need to go to the calculator or you want to do some side work, you could. So if you don't see right off the bat what 78 divided by 2 is, just do the side work. 2 will go into 7 3 times. 3 times 2 is 6. I get a 1. Drop down the next digit, which is 8. 2 will go into 18 9 times. So there's my 0 remainder. So I get 30 over 39. And our gut is 39 feels kind of weird, but let's see if they're both divisible by 3. I know 30 is for sure divisible by 3, and I have this feeling that 39 is too. So let's do a little dividing here. So let's see if 39 is divisible by 3. Well, 3 will go into 1, or 3 will go into 3 one time. 1 times 3 is 3. Drop down the next digit, which is a 9. 3 will go into 9 3 times. So 3 times 3 is 9. There's my 0 remainder. So these are both divisible by 3. So 39, again, you might feel a little weird, but it can be reduced further. So we divide top and bottom by 3. Well, 30 divided by 3 is 10. 39 divided by 3 we already know is 13. There are no common factors. The only factors of 10 are 10, 5, and 2. None of those are factors of 13. So our final answer is 10 13ths. Your dog has eaten 10 13ths of that box of treats. Okay, so there you have it. It was kind of a longer worksheet. Each of the three topics were kind of beefy. So make sure you understand how to find a prime factorization. Make sure you understand how to check if two fractions are equal and how to build equivalent forms of fractions. And then make sure that one way or the other, you know how to reduce a fraction. Whether you do the GCF, the prime factorization, or some hybrid method, I don't care whichever one gets you successfully to the lowest terms is fine.